Hey guys, welcome back, and I'm very excited to have you back with us for our fourth session of Introduction to Linux OS. My name is Kevin Downs, and I'm going to be instructing you today. So today we're going to be going over UNIX processes. In our last session, we went over text editing, types of editors such as ed, ex, and vim. We also went over some basic editor tasks with vim. We edited multiple files. We went over some named buffers. And we also showed you how to start up a vim file and edit within that file. Today, we're going to be going over the UNIX process model, process states, and monitoring and controlling processes. The UNIX process model is a simple and powerful abstraction for running server-side programs. It provides a helpful way to think about dividing a web app's workloads and scaling it up over time. Linux uses the process model for a web, worker, and all other types of dynos. So you can see here we have this graph here. So we can get multiple different processes running. We can have web 1, worker 1, clock 1. And on top of that, we can have web 2, worker 2, and above that we can have worker 3 and worker 4. And all this is saying is that we can have multiple processes and jobs running at the same time in Linux. And they can be stacked on top of one another, or they can be running alongside one another. So there's a lot we can do within the UNIX model. So on our next slide here, we're going to look at process states. In a multitasking computer system, processes may occupy a variety of states. These distinct states may not be recognized as such by the operating system kernel. However, they are a useful abstraction for the understanding of processes. So you can see here we have processes that can be running, they can be waiting to run. We can have processes that were blocked. We can have processes that were swapped out and blocked, such as page file and swap space. We can have processes that were swapped out and waiting. We can have processes that were created. And we can even have processes that are terminated. Okay? For right now, we don't have to worry too much about process states. Just be familiar with some of the basic ones, such as terminated, which is going to mean that a process is no longer running. And we're going to have a running state, meaning the process is running. Or we might even have one that's waiting, meaning that the job's ready to go, but it's waiting to run based off of some given circumstances. Okay, so that's going to be the main ones. And be familiar with what kind of memory they're using. So in here, these processes aren't using any memory. These guys were using the main memory. And then on the bottom here, these guys are using some of our backup memory, such as swap space or page file space. Alright, so to manage processes, the operating system tracks processes through a 5-digit ID number known as the PID or PID. This is the process ID. Each process in the system has a unique PID assigned to it. PIDs eventually do repeat because all the possible numbers are used up and the next PID rolls over or starts over. At any one point, no two processes with the same PID exist in the system though, because it is the PID that Unisystem uses to track each process. So that's important to know that at one given point, no two processes are going to have the same PID number. However, a job could end, and later on down the line, its PID number can be used for a different process. For starting a process, when you start one, such as running a command, there are two ways you can run it. You can run it in the foreground, or you can run it in the background. Foreground processes, by default, every process that you start runs in the foreground. It gets its input from the keyboard, so we type in our command, and it sends its output to the screen. So it sends the command output to our screen so that we can look at it and see what it did. An example of foreground processes is the ls command. So ls will list all files in the current directory, as we know. So let me open my VirtualBox here. Let me log in. So I'll type in ls, and I'm going to hit enter, and this is going to run it in the foreground, and you'll see it sends output to the foreground of the terminal here. Okay, so this is how you run a command in foreground. By default, this is what we're going to be doing most of the time. And as you can see here, it says the process runs in the foreground, the output is directed to my screen, and if the ls command wants any input, which it does not, doesn't need any input, it waits for it to run from the keyboard. Okay. While a program is running in the foreground and is time consuming, no other commands can be run. meaning no other processes can be started, because the prompt would not be available until the program finishes processing and comes out. Okay? So on our machine here, we can see this happens pretty quickly. As soon as I type in ls, it runs almost immediately. Okay? But from the time I hit enter to the time that it outputs all of this files here, nothing else can be typed in. Okay? So that's what this PowerPoint's saying. Is saying that while we're running a command in the foreground, nothing else can be run. Okay? So I can show you a quick example of a process that would hold up your terminal. So if I do sleep 60, you're going to see that it doesn't output anything, and I also don't have a prompt anymore. Okay, you can see that this prompt isn't showing up. It will let me type things, okay, but it's not actually going to let me output anything. Okay, you see I type in date or ls or even pwd, and it's not letting me actually type anything in or any commands in. Okay, so I would have to wait for that command to finish before I could actually type anything in. Okay, and all this command is doing here is telling the terminal to go to sleep for 60 seconds. Okay, so we could wait a minute for it to free up. I'm going to go ahead and stop it now, though. With Control-C, as we learned earlier, we'll stop the process. Okay. The other way to start a command is actually running in the background. A background process runs without being connected to your keyboard. If the background process requires any keyboard input, it waits. The advantage of running a process in the background is that you can run other commands. You don't have to wait until it completes to start another. Okay? So I can actually run multiple commands at a time and not have to wait on one or the other to complete. Just be aware that while you're running multiple processes in the background, that these are using resources such as RAM. So if you have tons of jobs and tons of processes running, this is going to hold up your machine, and if it starts getting slow, you might want to start finishing those jobs or wait for them to finish before you start running others. The simplest way to start a background process is to add an ampersand. Okay, so that's this little symbol here. So you want to add an ampersand at the end of the command. Okay, so if I go back to my machine here, and I go ahead and run ls, oops, so my machine, let me clear the screen here so you get a better view. So I do ls, and I put ampersand, it's going to actually run this process in the background. Okay, you see it actually outputs for us, because as you know, ls doesn't actually need any input. Okay, I can also do that with that sleep command you saw just a moment ago. So sleep 60, and I can put ampersand. You'll see that's now actually running in the background, and I don't have to worry about it anymore. Eventually this will time out and tell us that it is finished. So let's go back to our PowerPoint here. Oops. So as you can see here, it says, here is the ls command wants any input, which it does not. It goes into a stop state until we move it into the foreground and give it data from the keyboard. The first line contains information about the background process, the job number, and the process ID. You need to know the job number and manipulate it between the background and the foreground. Press the enter key and you will see the following. So let's go back to our virtual box. So on your machine, you can go ahead and type ls space ampersand, which is going to be above the letter or the number 7. So you just have to hit shift 7 and I'll type in ampersand. It's going to run that in the background. It's going to output ls for us. You'll just hit enter and you'll see this line here. It's going to tell you that ls command finished. You also see that our sleep 60 command finally did finish. Okay. So you'll see here the job number, which is 2. So sleep 60 was our second job. And then you'll see 3 here, which was that ls command. That was our third job. You also see a little minus sign. This indicates that this is the last job that was run on your system. Okay. And as you can see here, that's what it's explaining. It's saying this first line here tells you that the ls command background process finishes successfully. So it tells you it was the first job in this example and that it finished, and this is the command that was run. On our next slide, it's going to explain in depth a little bit more about this process management and listing running processes. So you can see it's easy to see your own processes by running the command ps. And it will output some info as as follows. So if I go to my VirtualBox here, I type in PS and hit enter. It's going to show you some jobs that I have running. Now, as you can see here, it has bash, which again is just our terminal. Okay, so it's this terminal emulator that's running. That sleep command that I had running. Okay, and then also the PS command itself. Okay, so I typed in the PS command, so it's telling you that command was also ran. You'll see in this first column is the PID, or process identification number. Okay, the terminal it was ran on in this middle column here, and then the command itself in this last column. Okay. So along with that PS command, one of the most commonly used flags for PS is the -F command, okay? Anytime you see the word flags, that means that an option is set on the command itself. So every command is going to have multiple options and flags that you can use with it to actually alter how it runs, okay? And this is very powerful and useful because you can add some options to your commands to output some more things for you. So in this one particular, it's talking about the -F option, or full. And this will actually provide a little bit more info than just running PS by itself. So we can see here we ran PS. Now if we do PS space -F, we actually get a little bit more info here. So in this first column, it's going to tell you that Kevin was the user that ran the command. Second column is going to tell you the process ID. Okay. Third column is PPID, which is going to be parent process ID, meaning that the original job that ran created this command. Okay, so we have things called child processes. So it is possible that you run a job or a process, and then because of that, another job or process runs and starts. Okay, so if that were to be the case, you would see a parent ID, and then you would also see a child process. Okay, but don't worry about that too much. For now, just recognize the fact that this PPID stands for the parent process ID. Okay, this shows you the start time, and this is in military time. Okay, so this tells you this was started at 10:48 p.m. And then this tells you what the command was here on the last column. Back on our PowerPoint, let's go ahead and go to the next slide here. So we can monitor the process in Linux in many different ways and methods. We just saw one using the PS command. We can also use a command called top, which I talked about in our last session. And this shows you the CPU usage as well as many other processes running. Okay, so let me go ahead and spin up top for you on here. So if I type in the word TOP and I hit enter, and you can go ahead and do that as well on your terminal, it's going to pull up this nice big long list for us. It's going to show you all these different processes running. Okay, if we look at the top here, it shows you the CPU usage percentage. So not a whole lot getting used here. You can even check that out in the middle column here. It shows you what process is running as well as how much the CPU is getting run. Okay. Shows you how much memory is available here, how much swap is available here. Okay. Now another helpful function at the top is I can actually do shift and then type in right arrow, and it will actually sort it by processes that are using up the most memory here. Okay. As well, I can do shift to the left. It's going to shift it and show different processes using the most CPU usage here. So to get out of top, I can just hit Q for quit. Okay. And again, once you quit out of top, you'll see that it's no longer a live feed, but that output is still going to stay for you there. Okay. I'm going to go ahead and clear my screen so you can see. So useful things to know about top command is that it just shows you different programs here. It shows you which ones are using CPU, which ones are using memory. Okay, and it's also a live feed of what's going on. You're seeing in real time how the processes are running. Okay, so I'm gonna hit Q again to exit out of here. One more helpful thing about top. Let me go back to it here. If you kind of forget how to use it or you're not sure what you're doing, just press H for help. And I'll actually show you some helpful commands here on top and things you can use. Okay. Again, to get out of here, you can type Q or escape like it says at the bottom here. So I'm going to type in Q for quit. I'm going to type in Q again to get out of here. Clear my screen. Heading back to our PowerPoint. We can use PS command to check the service is running and seeing the tree of the process and also identify the PID of that process. So if you want to see the process ID of a command, PS is a good way and a quick way to check that out. And we can also kill the process which is putting a lot of load on our CPU. Okay. So a lot of times when you're administering a system, such as myself at IBM, I have processes that are using up a lot of CPU, and I need to kill them so that my machine can get back some of its CPU. So I'll have to run that PS command. I'll see what processes are running, and I'll also run top to see which ones are using the highest amount. And from there, I'll take the process ID and I'll kill it so the system gets some of its resources back. Okay. Let me go ahead and show you that real quick. So I'm going to start that sleep command again. And I'm going to put it in the background. And if you guys remember to put it in the background, we use the ampersand symbol. Okay, I'm going to hit enter. So now we can see that process is running in the background. So we see it's job number 2. And it actually gives me the process ID here. But I'm going to go ahead and type in PS. You can see here we actually have 2 processes running for sleep. I'm going to kill them both. I'm going to do it one at a time. So to kill it, I'll type in kill. And then I'll type in the process ID here. Okay. The nice thing about the terminal is you can actually copy and paste if you like to. So I can highlight that number. I can right click and press copy. And then I can paste it here if you don't want to type it out. Okay. And then I'll run PS command again. Ooh, so interesting. You'll see it didn't actually kill it. So what we're going to do is we're going to do kill -15, which means kill that process, but do it gently. And we're going to copy and paste that again. Let's see if it'll kill it this time. There we go, and you can see that time that did actually kill the process and that it finished here. Okay, we're going to kill that other one too, so we'll do kill. We're going to do -15. I'm going to copy that process ID number. We're going to kill that off. We're going to run PS again. Let me clear my screen so you can see what I'm doing here. We're going to do PS, and you can see, oh, it's still there, actually. Let me try it one more time. Okay, so we're going to try something else here. We're going to do a kill -9, which means kill it immediately and don't do it nicely. We're not going to be polite about it. I want you to stop now. So we'll take that process ID. Let's see if it stopped at that time. There we go. That time it actually killed it. Okay, so I'm going to go ahead and add that info into the PowerPoint slide for you guys. So that kill -15 will kill the program gracefully, and it's going to allow it to actually run some code and finish out what it's doing. As you can see, though, sometimes that doesn't always work, and we need to actually kill the program immediately. So we can do a kill -9, and this will terminate the program immediately without running any code before exiting. Okay. So I always recommend just trying to run that kill command first. Clean up this slide for you a little bit. Okay, so I always recommend running that kill command first with the process ID. If that doesn't work, you can try the kill -15 and process ID. If that still doesn't work, you can do the kill -9 process ID. So you want to usually do it in that order. You want to try and shut it down as gracefully as you can without being too abrupt with it. So in summary, we went over the UNIX process model. We went over process states. And we went over monitoring and controlling processes. And we even got a little bonus info there, as you can saw. as you were able to see and watch that some of the processes weren't exiting. So we actually used some different flags on that kill command to actually stop the processes. The next session, we're going to be covering a lot of info. We're going to be covering file system organization, file types, file and directory naming rules and conventions, commands for navigating the file system, introduction to inodes, ownership, permission, and dates, manipulating files and links, determining disk usage, and other file system utilities. And guys, if you're struggling to kind of catch on to these things, if you need additional help, please follow these links and look up the private tutoring sessions for system administrator management. There are weekly and monthly plans available. There's also Linux and Bash scripting private tutoring sessions available. As always, thank you so much for joining me. I really enjoyed having you. I hope you enjoyed kind of watching and going through controlling some of these processes. And I really hope to see you next time on our next session.